All right, today we're going to look at properties of the atmosphere. If we look at the gases that make up the atmosphere, 99% is made up of nitrogen and oxygen. Nitrogen is 78%, so that means when you're breathing in, most of what you breathe in is nitrogen. Our bodies don't use it, so we breathe it right back out. However, when we breathe in oxygen, which makes up 21% of the atmosphere, our body converts it to carbon dioxide through respiration, and we breathe that out. Of the other 1% of gases in the atmosphere, two of the important ones that we're going to be talking about in this unit are carbon dioxide and water vapor. The amount of carbon dioxide is very small, but it's an important gas for several reasons. One, it's what plants need for photosynthesis. They take in carbon dioxide, convert it into glucose and oxygen. Glucose is the energy that we need, that we get when we eat plants or eat animals that eat plants. But also carbon dioxide is one of our greenhouse gases that helps to trap heat for our atmosphere. Greenhouse effect is very necessary because otherwise the earth would be too cold, water would be frozen, and it would not be able to support life. The problem is when we put too much carbon dioxide through burning fossil fuels, that more heat is trapped. Water vapor is also an important gas. The amount varies depending on the water cycle with condensation, precipitation, evaporation. Some parts of the world have more water vapor than others depending on how wet or dry it is. But it's important for our weather patterns, and water vapor is also a greenhouse gas. When we look at the structure of the atmosphere, it is divided into layers. If we look at air pressure starting at the surface and going up in altitude, pressure decreases. You can see at the image at the bottom where pressure is higher, the air molecules are more compressed. And as you go up in the atmosphere where there's lower pressure, the air molecules have moved apart, and so the air is thinner. That's why when you go up in altitude, it's harder to breathe. When climbers climb Mount Everest, a lot of times they have to take oxygen tanks with them because when you breathe in at that high altitude, you're just not getting the same amount of oxygen as you would when you're breathing at sea level. Next, we're going to look at how heat is transferred through our atmosphere. The energy comes from the sun to the earth. It travels as radiation. Radiation is heat that can travel through empty space. Like if you walk near a fire, you can feel its warmth without touching it. Or if there's a pot on the stove, you can put your hand near it and feel the heat. You don't have to touch it. To have heat transferred by touch, that is called conduction. So when sunlight enters the Earth's atmosphere through radiation, it's absorbed by the Earth's surface. The air that touches the Earth's surface is warmed by conduction. So that would be like if you touched a hot pan on a stove, it would burn your hand because heat has been transferred by contact. All right, once that air is warmed up when it comes into contact with the ground, warm air and warm water is actually less dense than cold air and cold water. So the less dense heat rises. That is called convection, where heat is transferred by the less dense material rising, the colder material that's more dense sinks. If you live in a two-story house, or if you've been in a building, a lot of times the upper floors will be hotter because that warm air has risen and the cold air sinks. This also happens in our atmosphere. So we have that solar energy that reaches the Earth's surface through radiation. It's absorbed by Earth's surface that causes it to warm. When it's heat, the gas molecules expand, which makes them less dense. They rise and carry heat upward through that process of convection. As it rises, temperatures decrease as you go up in that first layer of the atmosphere. So the air becomes more compressed and more dense, and causing it to sink back to the surface where it warms again. This is important when we talk about cloud formation. Convection causes warm, moist air to rise, and as it cools down, the moisture in the air condenses, which forms clouds and leads to some of our weather patterns that we'll be discussing this unit. All right, so of the solar radiation, not all of it reaches Earth's surface. Only about 50% is absorbed, because some of it is absorbed by clouds and atmosphere before it even gets to our surface, like the ozone layer, which is up in the stratosphere, the second layer of our atmosphere. And then 30% of it's reflected back into space. If you've ever seen pictures of the Earth from space, it looks like it's glowing. That's actually the light that's being reflected. All right, so because of the heat transfer through our atmosphere, we get temperature gradients. So if you look at this graph, this is similar to one that we did in class. You're looking at altitude on the y-axis. So the x-axis, which shows us temperature, that's at the Earth's surface. So that first layer, the troposphere, the temperature decreases as you rise in elevation. Because remember, the Earth's surface, which had absorbed the solar radiation, is warm, and the air that touches the Earth's surface is warmed by conduction. As you move up in altitude, the temperature decreases until at about negative 58 degrees or so, it pauses and starts to increase again. That pause is called the tropopause. Above that is the stratosphere. Through the stratosphere, you can see that temperatures increase. This is due to the ozone layer, which absorbs UV radiation. Once you get to the top of the stratosphere, the temperature pauses once again. That's the stratopause. And then it starts to decrease through the mesosphere. Mesosphere is one of our coldest layers because it's far from Earth's surface, so it's not getting that heat through conduction. And there's no ozone to absorb heat. Then we get to the outermost layer, the thermosphere. The prefix therm means heat. It is our hottest layer. All right, so looking at each individual layer, we'll start with the troposphere, which is closest to Earth's surface. This is where all of our weather occurs. Remember that the air pressure is greater the closer you are to Earth's surface, so most gas molecules are in this layer of the atmosphere, so that's where our water vapor is. So our clouds form, that's where we have precipitation, storms, so all the weather occurs in the troposphere. And again, the air close to the ground is warmer because it's heated by conduction, where it comes into contact with Earth's surface and it decreases with altitude. Above the troposphere is the stratosphere. Stratosphere, the temperature increases with altitude because the ozone layer is absorbing UV radiation. Now you can see in this diagram there's 3 types of UV radiation: UVA, UVB, and UVC. We need ultraviolet radiation at Earth's surface because that is what drives photosynthesis. However, there are harmful UV rays. UVB and UVC are those that cause skin cancer, that can actually damage plants and other materials. So the ozone layer provides protection from the harmful UV rays. Above the stratosphere is the mesosphere. Again, that is our coldest layer. There's no ozone. It's far from Earth's surface. One neat thing that happens in the mesosphere is that when meteors enter our atmosphere, they burn up by the friction of the gas molecules. This usually happens in the mesosphere. So if you've ever seen a shooting star, it's actually not a star. It's a burning rock. And again, the mesosphere protects us because it causes these meteors to burn before they actually hit our surface. The outermost layer is the thermosphere. It is our hottest layer. Temperatures increase as you rise due to the UV radiation from the sun. We also have the auroras, the northern lights and the southern lights. That's an interaction with solar radiation. And you can see those if you're in the higher latitudes, like in Alaska and Canada, or also in the southern hemisphere, Antarctica, southern part of Australia, especially in the wintertime where nighttime is longer. All right, so I want to take a minute to talk about the ozone in the stratosphere. If we look at the chemical makeup of ozone, it's made up of 3 oxygen atoms. The chemical formula is O3. The oxygen that we breathe, the oxygen molecule is made up of 2 oxygen atoms, and that is O2. So the ozone that's up in the stratosphere, the ozone layer, that's the one that protects us from the harmful UV radiation from the sun. We also have ozone that can form in the troposphere and is considered a pollutant. It's one of the main ingredients in smog. Ozone can be created or destroyed by the UV radiation, and it's a chemical reaction that's constantly occurring. So what happens is UV radiation can break apart that O2 molecule into individual oxygen atoms, and then those individual oxygen atoms combine with another O2 molecule to form ozone. And so that ultraviolet ray has been used in that reaction and doesn't make it to Earth's surface. Now, humans have interacted with this chemical reaction in a negative way by releasing certain ozone-depleting compounds into the atmosphere. One of those are chlorofluorocarbons, or CFCs for short. And what happens is the chlorine from the CFCs actually steal one of the oxygens from the ozone molecule, breaking it down into O2. And so now we are breaking down ozone faster than it's being created. Because of that, we experience a thinning of the ozone layer. You can see the area in blue is where the ozone hole formed. The hole is just an area where the ozone is thinner than normal. Good news is we've actually decreased the size of this hole. Back in 1987, the Montreal Protocol was passed, and what it did was an international agreement that we would stop putting CFCs and later other ozone-depleting compounds into the atmosphere. And so you can see when we decrease the amount of CFCs, we've decreased the amount of chlorine compounds that have affected the ozone hole. So the hope is, and the patterns show, that the ozone layer should recover by 2050. If you go on the webpage under day 2, you should be able to see a video clip on ozone and how it forms and how CFCs have broken it down. But the last thing that I want to do, if you look at the map at the bottom of your notes, we're going to talk about a type of weather map that shows us temperature. So let me switch screens here.